Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. So in this video I would like to draw a phase diagram for both the metals that will be soluble into liquid and solid state. So in my previous video it will be talking about the cooling curve for the same concept of both the metals that will be soluble into liquid and solid state. So here I will draw a phase diagram. So you will easily study about the different phases for both the metals, or you can say the binary metal alloys. So which will be having 100% solubility into the liquid and solid state. So let's take two metals as an example over here. So we are taking one metal as a copper. So copper having a melting point around 1084 degree centigrade, and another metal, because here it will be talking about two metals. So one is a copper and second that will be the nickel. So nickel having a melting point around 1485 degree centigrade. So these two metal, and that will be the melting point of both the metals. So melting point generally it will be representing as a temperature at which all the solid phase that will be converting into the liquid phase. Now these two metals it will be considering as a binary metal alloys, and these two metals it will be act as these kind of situations like which will be soluble into liquid and solid state. So let's start with the draw of phase diagram for copper nickel system. For phase diagram, first of all make a x-axis and y-axis. So here into the x-axis that will be the representation of weight percentage of composition. This y-axis it will be representation of temperature in degree centigrade. So here I would like to draw that particularly phase diagram for copper nickel systems. So for making a x-axis, or you can say weight percentage of compositions, so that will be plotted onto the x-axis. So just you can see. So here that will be the weight percentage of copper and weight percentage of nickel. So one end that will be the 100% to 0, and for the nickel it will be 0% to 100%. Now it will be onto the y-axis, and that will be the representation of temperature into degree centigrade. So let's say for the copper it will be around 1084 degree centigrade, and for the nickel that will be the 1485 degree centigrade. So according to that melting point of both the metals, I would like to make a one scale onto the y-axis for the temperature. So let us see. So according to the range of the temperature, just you can see here 400, 800, 1200, 1600 and 2000. Same it will be from another side. So now according to the given melting point for copper and nickel, just you can take that temperature range. So I would like to talking about this point. So that will be the 100% copper, and from another side that will be the 100% nickel. So that 100% copper or 100% nickel that will be act as a pure metal. So just point out the temperature for the pure metal of copper and nickel. So just you can see for the copper that will be 1084. So that will be in between 800 to 1200. So around this point. So that will be the indication of 1084 degree centigrade. So that will be the melting point of copper. And for the nickel, So around 1485. So that will be around this. So that will be indication as a 1485 degree centigrade. So after getting the 2 points from the copper and nickel side with respect to that melting point, then I will join these 2 points like this. So why such kind of line of the phase diagram? So that will be from the condition like both the metals that will be soluble into liquid and solid state. So how to draw the phase diagram, that will be already make a one video. So you will find a link in my description box. So you will easily understanding for this kind of case for the both the metals which will be having a soluble into liquid and solid states. So basically this upper line, it will be considering as a passing through the starting point of the solidification from the various cooling curves for the different kind of compositions of the copper and nickel. So this line is representing as a liquidus line. Liquidus line. And this below line, generally it will be drawn from the end point of the solidification process for the various cooling curves for the different compositions of the copper and nickel. So that will be as a solidus line. Now from the copper nickel diagram, you would like to also understanding about the lever arm rule, how to draw the cooling curves, weight percentage of the liquid and solid at the various conditions of the temperatures and compositions, and how much percentage of the liquid and solidified your compositions with some cases, and the detailed introduction about the microstructural view at the different stages of the phase diagram. So basically this phase diagram that will be help for easily understanding the various kind of phase that will be exist in between the various compositions with respect to the various set of conditions of the temperatures. So let's take one examples over here, and that will be around 55% of copper and a temperature, you can say 1300 degree centigrade. So what should you find? That will be the weight percentage of solid and weight percentage of liquid, and also discussing with the microstructure and the cooling curve for the same conditions. So let's start to understanding with this condition. So that will be the condition number 1. So just you can start with the first, and that will be the 55% of copper. So just you can see that will be the 100% copper, 90, 80, 70, 60 and 50. So in between, that will be the indication of 55% copper. And just you can see at 1300 degree centigrade. So almost around this 1300 degree centigrade. So just you can make the one vertical line from the composition line and one horizontal line from the temperature line. So this is the composition line and this will be the temperature line. So the temperature line, or you can say horizontal line, that will be intersecting the liquidus line. So that will be making the one intersecting point. Second, it will be intersecting with the composition line, so here. And third, it will be intersect with the solidus line. So this line, it will be known as a tie line. So just you can note down. So after the tie line, which kind of phase that will be existing into the phase diagram. So this is our liquidus line. So above all the portion of the liquidus line, that will be known as a 100% liquid. 100% liquid of copper and nickel. And similarly, for the below portion of the solidus line, that will be act as a 100% solid of copper and nickel. So in between the liquidus line and solidus line, that will be representation as a liquid plus solid phase. So here that will be the case number 1 for the 55% of copper and around 1300 degrees centigrade. So that will be the various points. It will be look like this, starting from the above. So that will be making a 1 point. So that will be known as a point P. That will be intersecting at a liquidus line. So this point it will be known as a Q. And in between the composition line and it will be the temperature line, or you can say around your tie line. So that will be representing as a point R. After it will be intersecting at a solidus line. So that will be representing as a S. And around room temperature, that will be indication as a T point. So in this phase diagram, I will discussing with each and every point of the various kind of microstructures and how much percentage of the liquid is being converting into the solid. So basically I am interested with the point number R. So that will be the case number 1. So that will be the 55% copper and 1300 degrees centigrade temperature. So how much liquid it will be converting into solid at the point number R. Right now I am discussing for the various microstructure it will be formed at the various points of the P, Q, R, S and T. So let us see the which kind of microstructure view of the copper and nickel for the 55% of copper. So starting with the point number P. So I already explained you all the portion of the above of the liquidus line, that will be 100% liquids. So let's see for the microstructure view at point P. So at point P, so that will be the 100% liquid of copper and nickel. So this orange, it will be indication as a copper, and one more metal, that will be the nickel. So both are having into the liquid state. So that will be the nickel. And the weight percentage of carbon at this place, that will be around 55% of copper. So here that will be indication as a 55% of copper. So remaining 45, that will be from nickel in the form of liquid state. So that will be indication as a 100% liquid at point P. So by the cooling from the higher temperature, or you can say around, just you can make a projections, so around 1900 degrees centigrade for the 55% of the and 45% of the nickel, that will be in the form of the 100% liquid phase. Now we will discussing for the second point, and that will be this composition line. It will be intersecting at a liquidus line. So that will be the point Q. So when it will be touched the liquidus line, so that will be indication of the starting point of the solidifications, because we already discussing in my previous video. So that line, or you can say liquidus line, which will be indication as a all that solidification starting points. So once it will be touched the liquidus line, that means what? It will be the starting point of the solidification process. So here that will be the formation of nuclei. So just you can see one of the metals, so which will be having a higher concentration. So right now the 55% copper. So copper, it will be having a majority. So the copper, that will be starting to convert into the solid. So copper, it will be making a tiny particles at point number Q, and rest of the others of the coppers, it will be still into the liquid state. And for the nickel, which will be totally into the liquid state. So just you can see these copper parts, it will be making a tiny particles, or you can say tiny solid particles, or in technical language it will be a formation of nuclei. So that will be the starting point of the solidification process. So which metal that will be into the majority? It will be starting of the solidification process. So here nuclei, it will be formed with copper for this case, because it will be the 55% of copper. If you are taking the points like 55% of nickel, so at that time it will be the formation of the nuclei that will be from nickel. Likewise this. So that will be nothing but it will be the starting point of the solidifications, and it will be the mixture of copper and nickel. Then after talking about a point that will be onto the tie line, and that point it will be representing as a R point. So for R, that will be your microstructure. So this microstructure is belongs to the point number Q. So just it will be noted down like this. Now I will explaining about point R. So this is at point R. So what happens, some of the portions it will be converting into the solid from the liquid phase, because in between Q to S, that will be the total region as a liquid plus solid. So some of the portions still it will be into the liquid, and some portions it will be converting into the solids. So just you can see some of the portions like copper and nickel, it will be transferring into the solid, and rest of the others it will be in the form of liquid. So nuclei formation at point number Q, and this nuclei that will be having a growth and the nucleation growth, or you can say growth of nucleations towards the solidification process. So at point R, almost 40 to 50% it will be converting into solid. So how much percentage of solid at point R and how much percentage of liquid with respect to the 55% copper and 45% of nickel. So that will be also find later on with the help of lever arm rule, but here you can find out the almost 40 to 55% of solidification process is being completed for the copper and nickel. So this orange, or you can say these orange particles, it will be for copper, and green it will be for nickel. Then after at point number S, so that will be representation line as a solidus line. So at your solidus line, 100% solidification process is over, or you can considering as an end point of the solidification process. So at point S, just you can note down, so all the liquid of copper and nickel that will be transforming into the solids. So just you can see, so this orange color structure that will be indication as a copper, and this green it will be indication as a nickel. So it will be forms a 100% solid. So just you can note down 100% solid of copper and nickel alloy, and here that will be the case of both the metals like copper and nickel, which will be having a 100% solubility into liquid and solid state. So after the solidification process, it will be forms a single solids of the copper and nickel alloy. So here that will be the indication as a 55% of the copper is being present into this microstructure, and 45% of the nickel is being present for that microstructure. And after this S point up to the room temperature, or you can say at point number T. So just you can see it will be the rearrangement of the structure of the copper and nickel. So just you can see, so at point T, or you can considering as a room temperatures, so that will be making a alternate layer of the copper and nickel, and it will be making a different kind of grains. So that will be totally indication as a grains, and that one grain, it will be separated from the another grain with the help of grain boundaries. So that will be the microstructural view of the copper and nickel at a room temperature, which will be forms a single phase solid, because in the metals that will be having the 100% solubility into solid states. Now I will explaining about how to find the weight percentage of the liquid and solid with the help of lever arm rule. Then I will also discussing about how to draw the cooling curve for the different set of conditions. So let's see. So for weight percentage of the liquid and solids, so just you can make points at intersecting of the tie lines onto the liquidus lines and solidus lines. So here that will be the R point, it will be already there. So just it will be noted down as a X and Y point. So X point onto the liquidus line and Y point onto the solidus line. So just you can make a projections onto the X axis, or you can say composition line. So just you can see from the X point it will be projected onto the composition lines. So that will be the point. So I will considering from the weight percentage of nickel, right? So here it will be around 16% of nickel. Here 55% of copper, that's why it will be 45% of nickel, and from the Y point towards the composition line it will be around 86% of nickel. So now I am interested to finding a weight percentage of liquid and solid at point R. So that point it will be nothing but it will be your case number 1. So 55% of copper at 1300 degree centigrade. So how much percentage of liquid is present for this point and how much percentage of solid? So that liquid it will be converting into the solid. So for weight percentage of liquid, so for weight percentage of the liquid, just you can take the site of intersecting with the solidus line. So keep in your mind for the lever arm rule. So that will be from a lever arm rule. So that rule that will be help to find out the weight percentage of the liquid and solid of any kind of phase, right? So for weight percentage of the liquid, just you can take the site at the intersecting with the solidus line. So for this diagram, just you can see weight percentage of the liquid. So for which side that will be from the solidus line, it will be intersecting. So this Y point, right? So this will be your solidus line. So just you can take the distance R to Y. So RY divided by total distance of tie line. So XY multiply by 100. So how you will find a RY distance? So just you can take the difference for this projected line. So here that will be the 86% nickel and for R 45% of nickel. So 86 minus 45 divided by 86 minus 16 into 100. So around 58.57% of liquid is being present at point number R. So for your microstructural view, here just you can note down 58.57% of the liquid is being present at point number R. Now I will find out for the weight percentage of solid. So for weight percentage of the solid, just you can take the side at which the liquidus line it will be intersecting. So here that will be the X point, it will be intersecting with the liquidus line. So just you can take the distance for finding the weight percentage of the solid. So that will be the XR divided by total distance, and that will be XY into 100. So just you can see XR means 45 nickel minus 16 nickel. And 86 nickel minus 16 into 100. So that will be almost around 41.43%. So that much amount of solid is being present at point number R. So if you want to write like this, so at point R, 58.57% liquid and 41.43% solid is being present. So 100% liquid, it will be converting into solid. So how much percent? So that will be identified by the lever arm rule. So here for these conditions it will be 41.43% solid is already formed at point number R. And we already know at point S that 100% conversion from the liquid to the solid. So this lever arm rule that will be helpful for finding a weight percentage of the liquid and solid at each and every set of conditions of the compositions and temperature. Now if you want to draw a cooling curve at these conditions, so condition is same, 55% of the copper and 45% of the nickel. So that will be the point of the composition line Q and S. So just you can take a projections onto the y-axis. So this point and for this point. So this point it will be intersecting at a liquidus line. So just you can extend it like this. So this point, or you can say that will be one of the cooling curve, or you can say that will be the starting point of the solidification process. Right, so this point, and above for any compositions it will be forms of 100% liquid. So just you can see it will be look like this. So this is a point number A, and here that will be the 100% liquid phase, and that will be the binary alloy. So both are having a different melting points. So it will be look like this. So this is a point number B, or you can say solidification start. And once again this S point it will be intersecting at a solidus line. So below this line it will be forms 100% solid. So just you can see. So this is a point number C and D. So in between it will be the liquid plus solid, and after C point it will be the 100% solid. So this is a cooling curve. So just you can note down over here, this will be indication as a time, and this axis already it will be the representation as a temperature. So for this composition, just you can see around 1600 degree temperature it will be the starting point of the solidifications, and around 1200 it will be completion of the solidification process. For what? 55% of the copper and 45% of the nickel. So if you want to draw each and every cooling curves for finding a proper solidification temperature range, so that will be the different set of conditions that will be help for better understanding different phases it will be exist for the different metals. So I hope you understand for the both the metals which will be soluble into liquid state and solid state, and that will be the one of the most common example of the copper nickel alloy systems. So I hope you understand. So if you like this, then subscribe and share more the mechanical engineering tutorials. Thank you so much and keep watching.